Okay guys, so tonight we are going to look at percent yield. So in order to understand percent yield, what we first must do is make sure we're comfortable with a few definitions revolving percent yield. Alright, we're not really going too far beyond what we've already discussed. So first thing we want to do is look at what the difference in terms of theoretical yield versus actual yield are. The theoretical yield is the maximum amount of product that can be formed from the given amounts of reactants. All right, that's the definition. The theoretical yield, all right, is always going to be something that you calculate. When you do your stoichiometry problem, the answer is going to be your theoretical yield. The difference between the theoretical yield and the actual yield is going to be the amount of product which actually forms when a reaction is carried out. In theory, all reactions are 100% efficient. However, in chemistry, in actuality, when we actually do the experiment, we don't always get 100% efficiency. All right, some product ends up getting lost. Some product ends up getting lost in the beaker, or some product, the reactants don't go to full completion, or whatnot. All right, for some reason, we don't always get 100% efficiency. Now, really good reactions are 90 to 95% efficient. So, the actual yield needs to be given to you in the question. Now, in order to calculate a percent yield, the percent yield is going to be a ratio of the actual yield to the theoretical yield expressed as a percent. It's going to be the actual yield divided by the theoretical yield times 100%. What's going to happen is this is going to be a small number. This is going to be the larger number. If you find yourself getting a yield greater than 100%, you're wrong. You probably have your numbers reversed. All right, you probably have your numbers reversed. So flip-flop them. All right, because your yields are always going to be less than 100%. Because we're not God and we're not creating mass. So if we look at a sample problem, what is the percent yield of water if 138 grams of water is produced from 16 grams of hydrogen and excess oxygen? So in this question, 138 grams of H2O is our actual yield. What you need to calculate is the theoretical yield. So our first step is going to be writing out the balanced chemical equation. The second step is determining the actual and theoretical yield. The actual is given. It's at 138. The theoretical is going to be calculated. So our number of grams of H2O is going to be equal to 16 grams of H2, which is our mass A. We're going to go to mole A, then to mole B, then to mass B based on our mole map. So 16 grams of H2, we're going to divide it by the molar mass. Grams cancel. We're left with moles of H2. We're going to multiply it by our ratio of moles based on our balanced chemical equation. Moles of H2 cancel. We're going to convert moles of H2O to grams of H2O. Moles of H2O cancel. We're left with only grams of H2O. And we come to 143 grams of H2O. However, it's 140 grams based on 2 sig figs. Our last step is to calculate percent yield. Our percent yield is going to be our actual yield, which is given, which is 138. We're going to divide that by 140 or 143 grams, multiply it by 100%, and we get 96.7% yield. If we're looking at sig figs, it's 97% yield. All right. So what we have here, things to remember, the answer from stoichiometry is our theoretical. The amount given in the question is our actual. We need to do a stoichiometry question to figure out our theoretical. We divide those two numbers, and that gives us our percent yield. Have a good night.